going to start. The reason why we are doing this extra class is because we have this Eid on Thursday, which is a holiday. Also tomorrow I have a meeting at 11, so I cannot be in the class. So I thought I would finish this this structured threat intelligence exchange format, and then we can squeeze in another topic in the next week, which is about the SCAP, which is another standard for automation of security tools, right. So that would be an additional thing that we can do next week if I can finish it today. On Friday we will have class, so we will probably start SCAP on Friday, or maybe we can we may have to finish this on Friday. I am not sure, it depending on how long we want to stay here today. I think 1.5 hours would be good enough. So we were talking about this structured threat intelligence sharing format or data model, and we discussed that there are 3 kinds of there are actually 6 kinds of entities in this data model. Of course, the most extensive one is this STIX domain objects or SDOs, and then you have STIX cyber observables or SEOs, relationship objects SROs, and then extension definition object and meta objects and the bundle, and there is a patterning language which is used mostly inside these. So that is the different types of entities in the data model. And we saw an example on the STIX viewer, which is a tool that you can also use if you have a STIX file, and you can find many STIX files online. So basically you have these SDOs and SCOs, which are nodes in this data model, and then there are relationships objects, which are edges in the graphical representation of the data model. But the graphical representation is just for taking a look at various parts of these things, various components, but actually it is supposed to be parsed automatically by your security tools, so that you can actually have threat intelligence automatically coming to you through taxi protocol, and then automatically ingested by firewall and other tools, and certain actions are taken. Some intelligence can be used for getting more information on your security visualization, like SIEM tools and so on. And then we talked about some SDOs. So attack pattern SDO we talked about campaign SDO, we talked about course of action SDO, which is actually is a kind of a stub, a placeholder. Then we talked about grouping SDO for grouping certain threat intelligence objects, identity SDO for giving names or some kind of identity to entities and organizations, individuals, etc. And then we have incident SDO, which is again a stub, which basically is part of a threat report. It's that an incident has happened, and various parts of this thing. And then we came to indicator SDO when we stopped discussing. So indicator SDO is basically, so any kind of attack will leave some signature on your system, right. So, and they will leave a file in your file system, they will probably an imprint of the incident. It could be some IP address that they communicated on your network, or URL they communicated to on your network. They could actually change some settings. So, all those things we call indicators of compromise. So, indicators are IOCs. So, IOCs are very important part of threat intelligence, right, because if I want to caution you that my organization got attacked by so and so threat actor with so and so malware, and I want to caution you to say that you might be the next target. So, what you should be looking for? So, you should be looking for binary files which has a particular hash, for example, or you might be looking for traffic that goes to a particular IP address or particular URL, or you might be looking for some changes in the certain change in the Windows registry, or you might see a change in the some particular directory, this kind of stuff. So, these are indicators that you want to tell the other party that these are the things you should look for. So, you should have the entrapment or ability to actually look for these things, right. If you are not looking for anything, then you won't see anything, right. So, the visibility of your endpoints, visibility of your network traffic is very important, right. Without that visibility, without checking what is going on in your DNS, what is going on in your regular traffic, routing traffic, what is going on in your new files that are coming in, new certificates that are coming in into your system, if you do not observing them, then you are not going to get the benefit of indicators of compromise. But assuming that you have all that observability, then you want to see what you should try to observe. You cannot keep observing everything, right. So, everything is humongous amount of data that you have to observe. So, you have to know the threat intelligence to know what to observe, and that is what the indicators give you. So, indicators are one of the most important part of any threat intelligence. Sometimes this indicators are also you can say which kill chain phase this indicator belongs to, like is it something that you would see during command and control, or are you going to see this during the initial access, or whatever the indicator, whatever kill chain phase you might be in to see that indicator. And seeing that indicator, you would also know how far the threat actor has progressed in your system. If you see command and control traffic, you know already that you have been compromised with a malware, right, and that means initial access and then persistence, all those things have been achieved by the threat actor. So, he is deep into your system. So, that is the situation that you want to be knowing, and then you see the how the indicator is expressed. So, they have a patterning language. So, remember, like when we say that there are 6 components of STIX, the 6th component was a patterning language. So, this patterning language is we will see, we do not have to necessarily learn the patterning language in this class, but there is a patterning language. But however, there are many tools for creating threat intelligence, for editing threat intelligence, or for creating new threat intelligence, right. So, you can actually get some tools in which you can they will help you with this patterning language and all. So, you do not necessarily have to know the patterning language as good as you know the say regular expression and so on. So, an indicator also implies, maybe it may imply that you have a malware infection, or it may say that maybe some tool is being used against you, or you might see an attack, you might see that an attack pattern, or you might see a campaign, intrusion set and threat actor. So, more you know, so an indicator, for example, at some point initially when you see the indicator and you are the first one to seeing that indicator. So, nobody has told you through threat intelligence that this means this URL, if you see this URL, it means that you are infected by Emotet, right, botnet, right, let us say the first time. So, So, then you have to actually discover what else is going on in your system and so on, and then you create the threat intelligence. So, in the beginning you say, okay, I am seeing a bot. So, you will associate this indicator, this particular URL or IP address with, let us say, a bot. Then later on somebody would say, okay, so this threat intelligence is shared widely. Then another organization that says, okay, I found some more information about this this particular bot, and this bot is actually from Russian group APT28, let us say. I am just giving an example, hypothetical. So you say, okay, so this is APT28. So you will then add additional information into the indicator, saying that it is associated with threat actor APT28. And then you can say, okay, so somebody says, this is part of a particular campaign. So this is a closely spaced in time specific, like Ukraine war related campaign, right. So you might say, okay, so this is related to a particular campaign. So you can add additional information to this indicator. So the indicator threat intelligence gets enriched over time, right. It does not necessarily stay the static. Yeah. No, so I will show you an example, right. So this is a pattern. So this is, if you go and look up a STIX pattern, you will see that. So this is the pattern in which this has to be expressed, right. So what it says is that if you are doing a pattern based search, then you have to use this format. So that is what this is. So we will see that there are certain, this language is very specific to STIX. No, so the pattern language is part of the STIX specification. So STIX specification said that this is the syntax of the pattern language. This is how you write a pattern to express indicator or names, right. So this is what then anytime you want to say, okay, so this is you could see this pattern is very specific. This is a full fledged URL, right. You could have had a star.have8000.com also, right. So that would be more like, that would mean that this threat intelligence would have said that this domain every time you see, it is a problem, right. Here we are saying that this domain, this particular domain suffix is not a problem, it is just this particular specific URL is a problem, right. So this pattern will tell you that kind of information. And then when you get threat intelligence, you will get a file or a bunch of files each in this format, right. Then you have to do a JSON based parsing, and then how you process that information is up to you. So today's many tools has the ability to parse it. So when you get this, you actually connect the taxi feed into those tools, and the tools automatically download the latest STIX files and then process them and do certain things. You can, but what they do is based on what has been programmed into them. So you might add additional programming if there are hooks to do that, to do more intelligent stuff with it. So this is the indicator SDO. You can see that it's a type, and this is STIX 2.1 version. This has a STIX patterning language used here. So pattern type and pattern are usually close by, but in JSON it does not matter. This is a key value pairing, right. JSON language is basically key value pairing. So the order does not matter. This is the ID, which is very important. It has to be unique, created and modified date, name. They gave a name same as this thing. It does not have to be the same. There is a textual description, and then there is indicator type, and then when it is valid from. So not every information that is required, that is possible, has to be there, right. So but there are certain the ones marked with R, must be there, the others are optional. So, more enriched your threat intelligence is, better more information you will get. So, then there could be an infrastructure information you can get, like for example, when you know that a threat actor uses a particular C2C the command and control infrastructure, right. So, if you know more information about that infrastructure, you can actually put that in an infrastructure objects, right. And it may not be necessarily a C2C server, it can be some device which is part of their infrastructure database, or maybe some also what is the what targets, what are being targeted, that could be also part of an infrastructure. So, infrastructure is SDO is has all this name, infrastructure type, description, kill chain phases in which this infrastructure is used, and so on. So, that kind of information could be there. So, we already said that intrusion set, right. So, remember that we said the very first SDO we looked at was actually the attack pattern, right. So, attack pattern actually may be part of a campaign. Then we looked at a campaign, and a campaign may be part of intrusion set, right. So, an intrusion set may capture multiple campaigns or other activities that are tied together by a shared attribute. Usually that sharing is basically that they belong to the same threat actor, right. So, intrusion set is more long living. So, an attack pattern is usually a pattern that is used in multiple different campaigns, right. So, many campaigns use the same attack pattern, and an intrusion set may be many campaigns, right. So, many campaigns together will form an intrusion set. So, intrusion set SDO also has all this information. It may have aliases, first seen, last seen. You may also make some comment about its goals, what kind of resource level, are they very highly resourced or not so resourced, primary motivation, secondary motivation. Now, good thing about JSON is all of this information is textual, right. So, it is a string, basically every key is filled with a string. So, you can do many things with the string. One thing you can do is just display the string on your tool, so like on your SIEM or SOC, etc. But the other thing you can do is use NLP, natural language processing, to get more information out of these, to actually get more out of this information. Only bad thing about, only problem downside of that is that these are not required fields. So, if you have written, if you have created a natural language processing based processing of feeds, and this most of your STIX files that you are getting, they are not filling this kind of fields, then you are not going to get much out of them, right. So, you might get very little information. So, you have to see how enriched is your STIX provider is, like your STIX provider, if you are paying them money, they will give you a much more enriched STIX than if you are getting it for free from CERT or other organizations, right. So, they will give you the minimal. Location SDO is again something that represents the geographic location. So, why do I need that information? Sometimes that is important as to where this threat actor might be working from, like we usually get that kind of threat intelligence by analyzing the time of the day they attack. For example, if they are attacking at the time which seems to coincide with the work time of say Russia or China or something, we kind of get some idea. That does not mean that it is a foolproof way of understanding where the location is, but there may be other things, like for example, there may be strings of Russian language inside their malware, or there could be some previous malware that we have determined to be belonging to some particular Russian group or Chinese group. The fragments of code are common. All these things are not necessarily a full fledged proof of the fact that they belong to a particular location, but you could indicate that. So, so you could actually say, see here you see that the confidence. So, you can actually indicate the confidence with which this threat intelligence is being shared, right. So, if you are a threat intelligence analyst and you are very focused on Chinese threat groups, and you say that this is Chinese, this is from Shanghai or for example, and you put your confidence to be high or very high or something, then the consumer of this threat intelligence will take it more seriously. You can also have longitude, latitude information. Now, why do I need this? Because sometimes I can use this threat information to be displayed on a geographical map, right. So, this kind of information helps there. So, these are all about you know how you make use of the threat intelligence. So, there is a whole new field called human centered security, right. So, so there is so much threat information, so much vulnerability information, so much attack going on the systems. So, now there used to be a whole field of human computer interaction, HCI. You might have heard of HCI is a field of cyber security, which we have a professor, Professor Shruti Raghavan, who is an HCI expert. So, we also have cognitive science people who also look at HCI issues, and also design people in the design department, which also has this. So, this is getting more and more important. You will find that in the top conferences nowadays, I see that a lot of papers are on human centered security. So, this how you are going to visualize this threat information and whether that visualization actually helps in combating the threat actors are matter of research, and that's, but this information may actually help. Now, if you have threat intelligence, you cannot have malware information, right. So, if you find malware being used by a threat actor, you obviously want that threat intelligence to be spread, like be aware of this particular malware. Of course, you can provide a signature of the malware, like if you are a endpoint security company, or if you are a antivirus company, you will all provide the signature of that malware, right. So, you will send the signature of the malware to all your clients. But if you are a threat intelligence company, your job is not to directly provide a signature, but you want the consumer of your threat intelligence to know that you have noticed a particular malware, and you have certain data, especially you have indicators. You know what indicators would indicate that a particular malware has been found, or in your system, if you see those indicators, you can kind of assume that you are also infected by that one. So, here is an example of a malware SDO. So, here the main thing is name here. You see here they also gave a hash, although the name does not have to be a hash, but they have given a hash of this malware as a part of the name, also in the description, right. And it is connected, see in the description it has given more information, that it is connected to so and so info with so and so password, etc. It connects to some other thing, and it is a remote access Trojan, right. Now, you could have more information, like if it is a family. So, it is a family of malware, not just a standalone malware. It might have aliases, it may be actually used in specific kill chain phase, first seen, last seen. Usually this first seen information may be there, last seen is highly unlikely unless something that goes away. OS execution environments, like is it a Windows malware, is it a Windows 7 malware, or is it a Windows 10 malware? What architecture execution environment, like does it work for x86 or ARM or whatever, whether the implementation language is known, whether it is written in C, Python, whatever. Capabilities, it may have certain capabilities, right. So, like for example, it might do a privilege escalation, or it may attempt a lateral movement and things like that. And then some sample references, where will you get the sample, and then you can have this thing. Now, when we look at the relationship objects, you will see that malware are usually related to indicator objects. So, you may have a malware and there are a couple of indicator objects. So, I will relate the malware object to indicator object. So, that whenever I see those indicators, I will assume that this malware is seen. There is also an object called malware analysis. Malware analysis captures metadata and results of a particular static or dynamic analysis performed on a malware instance or family. So, it should be either a result or reference. These are the STIX cyber observable should be provided. So, what have I seen, right? When I analyze the malware, what kind of observables I have seen. So, and then you should not have the actual copy of the malware in the object, because that could be dangerous while you are parsing the malware object or malware analysis object. If you are actually putting the actual sample of the malware in raw or base 64 encoded form, you might actually accidentally have your consumer compromised. So, you should have it in a defanged manner, that is, you put it in the archived format or password protected format and so on. So, this is where this malware analysis object. So, what version, host, VM, like where did you do the analysis, virtual machine, what operating system, installed system configuration, all this analysis related, what analysis have you done on this malware. Now, when you look at the relationship objects, malware objects may be actually related to the analysis objects through a relationship object. This is additional information if you want to add a note to the threat information. So, informative text to provide more context or to provide additional analysis not contained in the STIX object or the marking definition object or language content objects which the note relates to. So, this is additional meta information. So, this is not going to be actually processed as such. So, you can have like the note, content of the note, you may also mark the author, you can give some reference to additional objects like URLs and so on, and confidence with which the note has been written, whether the note has been revoked, all this kind of information. Now, observed data. So, whenever you are going to do some, you are going to be attacked, you might, if you have a detection capabilities, as I was saying that you have to have the detection capabilities, then you have to have the ability to observe certain data such as files, systems, networks, and usually those are captured as STIX cyber observable objects or SCOs. So, it can also capture information about IP address, a network connection, a file or a registry key, etc. So, observed data is not an intelligence assertion, simply raw information without any context for what it means. It has to be actually related to other objects. So, it can be related to other SDOs or SCOs, or through the what we call a citing relationship. So, when you say this particular indicator was cited in this particular incident, then you can have a citing relationship. So, this is the observed data. So, it has this first observed, last observed, number of times it has been observed, what kind of objects have been observed, observed reference. So, usually this would actually be related to these SCOs or cyber observables. You can also have an opinion SDO, which is kind of like the note. but it is more about the it asserts something about the correctness information. So, usually the consumer of threat intelligence will add this opinion SDO before moving it through its organization or to another organization, saying that I strongly disagree with a particular object and provide an explanation why, right. An SOC operator might give an indicator 1 star in their TIP, the threat intelligence. So, because it is considered a false positive within their environment, right. So, you can add additional information by enhancing the file. So, that next person who will be using the threat intelligence will know that somebody has disagreed or somebody found it as false positive and so on. So, that is the opinion one. So, you can see opinion and object references, explanation, author, these are the main content. Now, report SDO, reports are usually the top level SDO. So, report basically contains the entire threat intelligence. So, when you are reporting based on your some threat assessment, like say Microsoft wants to put out a report, it can put out a report in the textual form, but if it wants others to also consume the threat intelligence in automation in their security automation systems, then they can actually put this as a report by creating the SDOs and SCOs and relationship objects, and then overall this whole entire thing will be a report object, right. So, the report object will now refer to all the other objects that are there. So, report object contains a list of references to STIX objects or the cyber threat intelligence objects included in the report, along with a textual description and name of the report. So, for example, Acme Defense Corporation, that is a bank that we talked about earlier. So, this particular campaign, that analysis may be represented as a STIX file, but it is overall the entire STIX file is represented as a report. So, report itself would contain the narrative of the report, while campaign SDO and other related SCOs would be referenced in the report content. So, here is a report. So, you say it is a type report, it has an ID which we can reference, created by another identity, remember an identity object. So, it might be created by let us say FireEye, or it could be created by Microsoft. So, you have an identity object that you can refer to know that what this identity is, created at this date and modified at this date. You can give a name. This is a threat report as well as a malware report. It is published when, description, and so on. So, and this object references, this is I am not showing the full file here. So, object references will now talk about malware SDO, it will talk about some indicators, it will have some relationship objects, all that stuff. So, in the entire intelligence about that particular case, Acme case would be part of this references, object references, and those objects references can then be looked up to see what they are talking about. Okay, so, that is report. Threat actor SDO are individuals, groups or organizations, and they may support or be affiliated to various intrusion sets, groups and organizations. They leverage their resources, and possibly the resources of intrusion set can be characterized by their motives, capabilities, goals, sophistication level, past activities, resources they have access to, and their role in the organization. So, see there is a lot of information you can add here. For example, what is their sophistication level, what resource level they have. You can have some data about primary motivation, secondary motivation, personal motivation, and first seen, last seen, etc. What kind of threat actor type, name, etc. So, you can describe a threat actor, and then that threat actor object, it has an ID. So, using that ID you can relate it to a campaign, or you can relate it to a intrusion set, or you can relate it to an attack pattern. So, tool, another SDO is a tool. As I said that there could be tools like remote access tools like RDP, or network scanning tools like Nmap that may be used by threat actors during an attack. So, you can describe the various tools that you noticed while analyzing the incident to tell the potential user of your threat intelligence that be careful, because they are using RDP. So, if you have an RDP which is not properly protected, if you have a remote desktop port open and you have a vulnerable version of Windows, you might be attacked by this actor, or you might be scanned by Nmap by this threat actor, right. So, do not answer to the Nmap scan, do obfuscation and so on. So, usually tool, what tool types, what kill chain phase it is being used, what version of the tool might be used, etc., are information that you want to have there. Now, if you are giving threat intelligence, you may want to know what vulnerability the threat actor is using, right, because eventually to compromise your system should have some vulnerability. Now, vulnerability, you may have unpatched system, therefore, you may have vulnerability, and the threat intelligence would say that for example, last week we had the XZ vulnerability, Linux XZ vulnerability that had a severity of 10, right. So, it had a CV number, I think CV 2023 something. So, that vulnerability was exploited by many threat actors. So, any threat intelligence that was produced when that was going on would reference that particular vulnerability. So, there should be a way to capture individual vulnerabilities. So, it should have external references. So, this usually would be reference to the National Vulnerability Database or CV database, name and description, and then you can have a description you will have the CV number, etc. So, you can actually parse the description or parse the name could be also CV. So, it could be the name also. So, that was the list of all SDOs. So, these are all the SDOs there is in the STIX 2.1 specification. Now, you have the observables. So, observables are what you observe. So, as you saw in the SDO, what you saw was more of the different types of data, like we have attack pattern, we have campaign, we have intrusion set, we have threat actor, we have malware, we have malware analysis, we have indicators, we have identities, we have location, we have notes, reports, we have opinions. So, all these things, different types of objects, right, that are relevant to a threat intelligence information. Now, what I want is that I want to describe what if threat intelligence is only as good if I can use it to detect the attacks or detect the presence of threat actor or detect the presence of malware. So, there has to be some observables, right. So, and observables are those that gets created because of the attack or because of some action by the threat actor, and those has to be then used for detection purposes or forensic purposes. So, if I am going to give you some threat intelligence based on what I have noticed in my system happening, then I should also tell you, okay, so here is an IP address from which I got nmapped, or here is an IP address from which I got to which my malware was communicating or my Trojan was communicating, or here is a URL that my Trojan was communicating, or I could say that this particular malware creates a file inside so and so directory, or it creates us this specific directory, or I could say that it creates this kind of a binary, inject this kind of a binary into DLL files, or I might say that this affects the network traffic in this way, that I SYN flagged, right, or I see a particular process being created or set of processes being created by this malware, or I see that there is some Windows registry key being created or deleted or whatever. So, I have to be able to express those. Yes. No, so indicator SGO will see is going to be related to this. So when I am describing, let us say, an IPv4 address, right. So indicator, if you go to the indicator, okay, so I think I have to, let us go and see the indicator again. Here. So you see in indicator, I am being very generic, right. So in this case, I am saying the indicator type is related to malicious activity and attribution, and I see this as a pattern, right. But this indicator does not say that this is an URL, right. So eventually I have to somehow, if I want to make more sense in an automated fashion, as a human, if I read as a human this whole thing, I will know that this is, they are talking about an URL indicator, right. But the same indicator object with the same indicator type, malicious activity, might as well contain an IP address or a registry key, right. So eventually what I want is that I also want to have a more semantics of an indicator. So what the SCOs are giving you are actually more semantically rich information. Then you can say with a relationship object that this is an indicator which indicates something, right. So that way you have more information, right. So you can think of this as, I do not know if you have taken a relational database course. In a relational database, I might have a relational for every type of SCO, I may have a table, right. So I have a directory, I have a artifact, whatever. So I can have multiple tables, and then I can have also table that like indicators, right. And then I will be able to have a foreign key that connects this indicator to a particular table. So that way I can do better queries, right. So there are 18 such different SCOs. So in this SCO, you see that so this is artifact object, right. So artifact object is usually for capturing an array of bytes as a base 64 encoded string or linking to a file like payload, right. So you see that here I can have either a URL or file hash, or I can actually have a payload bin, which is base 64 encoded string, right. So and one of these has to be present. So even though it does not say R, but one of them has to be present, otherwise this artifact object is useless, right. So if neither indicates to a file or if it does not indicate the binary, right. So now it is incumbent on the object creators to ensure that the URL is accessible to the downstream consumer. So you cannot give an URL that is local to you, right. So it has to be resolvable, right. Now this does not relate, see here you see that this observable has no relationship with any malware or anything, right. It is just a standalone object, right. Later on with relationship I have to relate this to something, otherwise this what good is it, right. No, these are all JSON. No, I am just saying that so sometimes information is kind of given in an out of context, like this is context free, right. So there is no context in this information. Relationship objects will bring context to this, right. So that's why I was trying to explain to how we design tables and stuff, right. So here is an autonomous system. We know the autonomous system is what like for example, IIT Kanpur itself is an autonomous system, right. So it has an AS number, it is your ISP, any ISP you have is an autonomous system, right. So, it is basically autonomous system is characterized by a set of IP prefixes, right, or in CIDR form, right. So, autonomous system, so it is basically each autonomous system has a unique number throughout the world, right. So, so if you look at the IIT Kanpur's autonomous system, so 202.3.77.16 I think. See, our autonomous system number is 55479, right. So, that is the IIT Kanpur campus network. We are given an autonomous system number, and this is the this thing. But in any case, so autonomous system characterizes. So, many times when we investigate a particular cyber attack, we try to figure out which autonomous system it came from, if it is at all possible, because or when we see an IP address, we try to figure out with a whois lookup or IP lookup which autonomous system, because then we can request that ISP, if that ISP is going to listen to us for knowing more about that IP address, if they are attacking us. Huh? AS number is unique, yes. So, it is basically related to IP address prefix, right. So, 202.3.77 I think /24, or do we have 24 bit? Yeah. So, 24 /24. So, 202.3.77.1/24 is IIT Kanpur's IP prefix on Airtel, I think, right? Is it? No, it is NKN. Okay. So, this is the IIT Kanpur got long time ago from the regional internet registry, and regional internet registry got it from the global internet registry. So, that is the unique to IIT Kanpur. So, this chunk of IP addresses is AS5545, whatever that number is. Right. So, directory object is basically mainly it has characterized by path and so on. Domain name object, the value here may resolve to reference. Here you can actually put the IP address it resolves to. Email address object represents a single email address. Email message is has to be decoded, the header has to be decoded, etc. So, whether it is a multi-part email and so on, you can have lot more information, or this is at least the required information. You can actually have this entire email message, but the problem is that because of privacy reasons, if you are going to produce state intelligence, create based on an attack, let's say this is a phishing attack whose information is being produced. You may not want to give all the information that is in the email, but you may give some information that is useful. File object, of course, if a file is created or something, or at least one of hash or the name of the file has to be there. IPv4 address, IPv6 address, MAC address, mutex object, network traffic. So, you may have arbitrary network traffic, you may give it a source and destination, source and destination addresses and ports, and you can give the traffic in pickup file or whatever, you can give reference to the pickup file. So, you can, but you may not always share the entire information. If a process is being created, you might give at least what process is being created by this threat actor or malware. If a software object is seen, then you can talk about this software object. URL is seen, then you can talk about the URL. You can talk about user account. Sometimes user accounts are created by specific names like root or admin or things like that. You can also, that may be a you may actually see a user account information for a social media account which was used to phishing attack and things like that. Windows registry key, so you may have key and value here. So you may see an X.509 certificate, a digital SSL certificate that is part of threat intelligence, that this particular certificate, remember, like in Stuxnet for example, they forged digital certificates. So there has been many attacks where digital certificates have been forged. So forged certificate attacks may be used. Now comes the relationship object. So we have SDOs, we have SCOs, and now we have to relate them, because otherwise it makes no sense, right. So I have lots of SCOs, and then I have some malware description, some description of some malware, I have some description of an intrusion set, a threat actor, but how are they all related to each other, right. So you have to have the relationship object, right, and relationship type will tell you what the relationship is. So for example, maybe an attack pattern uses a particular vulnerability or targets a particular vulnerability on the target system, right. So I would say that the relationship type is targets. So you see attack pattern. Now I am not describing the attack pattern because I have already an SDO which has all the information, right. So I have to just go there and get that information, and I have to go there and get this information. This is also an SDO, and then I am relating them by targets. So this is how I am doing the targets. So these are called the generic relationship objects. So there are many such objects you can create. So this for example, I can say that this indicator indicates, so in that case instead of targets I will say I will have an indicator ID here and a malware ID here, and I will say that indicates, right. So I can have a malware analysis, and I can have a file SCO object here, and I can say this file is created by this malware, right. So this kind of relationships can be described. So these are called generic relationship objects. So SDOs and SCOs are kind of nodes or vertices in the graph, and the SROs, the relationship objects, represent edges or lines between the nodes. So that is the graphical representation. There is also another kind of relationship called citing, right. So citing, for example, I can say citing of a particular indicator and where cited. So identity. So maybe a particular indicator, for example, an IP address was cited in an organization. So I can put that information here, saying that this indicator, so I can go and check what that indicator was. It could be a traffic, network traffic, it could be an URL, it could be a file, and where it has been cited, and I will say where was it first seen and last seen and all that information, how many times it has been seen and so on. So there is a citing type of relationship which is different from generic relationship, which basically relates in many different ways. Also, if you do not feel that you are a threat intelligence creator, or you are a threat intelligence consumer, and then you want to move that threat intelligence forward to somebody else. So you can extend this by 3 different ways. You can create custom objects. So here I am saying that I can do a new SDO, SCO or SRO I can define, which is less likely to happen, or I can define additional properties for an existing STIX object as a nested property extension. So typically done to represent a subcomponent or module of one or more STIX object types, or you can define additional properties for existing STIX object type at the object top level. So either you can nest it, or you can put it in the object top level. So, that is how you are extending. So, it is kind of like when you do C++ or Java derivation of a class, a subclass, then you add additional methods and additional data, right. So, same thing here, you do additional properties. To do this, you can do this as a nested, or you can do this as at the top level. So, you can use this extension to express use case specific objects or properties that go beyond what the technical committee could imagine while developing this standard. So, in the next iteration of STIX standard, some of this may actually make it to the standard, right. So, for now the good thing about JSON is parsing JSON is easy and flexible, right. So, if you are parsing, then you are basically parsing key value things. So, you can actually interpret that that way. Yeah. Yeah. No, you do not remove, right. So, let us say you have a malware object, right, and then you say that in my organization this malware had this certain additional attributes. See, malwares vary from organization to organization, same malware, right. So, I might add some additional properties. I am defining what those properties are, and I am doing this. Now, whoever is going to parse it, they will, while parsing, they will see that this is not in the original STIX specification. So, I am going to have to interpret it, right. So, we will say take it as key value pair, right, and then they might put it into a database or data structure or something, and then they can do whatever they want to do. So, producers and consumers of STIX are encouraged to use guidance provided by a particular section of this STIX manual for creating custom objects and extensions. So, we do not have to go into that level for us. So, just to know that it can be extended. Now, so we have meta objects also. So, for example, language content object. So, you may translate some threat intelligence and add language content. So, you might have noticed that some of the SDOs and SCOs had a language field, mostly see, you see that there is a language field here, right. So, you can actually say in what language are you putting this information, like for example, in Korea or Japan, all these things will be in Japanese or Korean and Japanese and stuff like that, right. So, that is not very relevant to us, but bigger information is that you might have also noticed that we have this in every object, we had this which we did not describe. So, object marking reference and granular marking, right. So, threat intelligence is often characterized by who I can share that information, whether the information is copyrighted and so on, right. So, I may say, okay, here is a STIX file and I am sharing with you, but you cannot share this forward, right. So, there is this protocol called TLP, right, the traffic light protocol, right. Traffic light protocol, basically if it is red, then it is highly confidential, you cannot forward it at all. If amber, then within your organization you can forward, and if it is green, then you can forward to anybody outside also, right. So, as a creator of the threat intelligence source, you might actually say that, okay, here is usually it is used for specific things, like where there is a, for example, identity, right, identity SDO or location SDO or traffic, this network traffic SDO or URL, this kind of information which might lead to various issues, you might want to put them with a traffic light protocol marking. So, and then so now there are two types of marking definition. One is regular object level marking, object marking, another is called granular marking. So, object marking basically says that the entire object, entire SDO, if there is a marking, so see if the entire SDO is marked as, let us say, red, then the entire object is not going to be forwarded. But if you want to, if you say this is green, but you do some granular marking that you cannot, for example, well this one you may not want to share the name or something, right. So, some specific property you cannot share, so that will be in the granular marking. Now, this marking information is not directly in the object, but it is in the separate meta object marking called marking object, data marking object, and then you will be relating this data marking object to the actual object, right. So, you will create a data marking object like this, and then you will say that this particular SDO or this particular report or this particular note has this marking. So, based on the marking, the automated tools will then decide whether to forward it or whether to suppress it, and so on and so forth. And then the last meta object is bundle object. So, bundle basically bundles all does not have any semantic meaning or context. So, basically it puts together a lot of SDOs, SCOs, SROs and meta objects into a single bundle, so that this entire bundle can be referenced with an ID. So, usually for useful for sharing information along across among the members of a particular group. So, this is the STIX patterning language, what it looks like. So, STIX patterning language is more than regular expression, as you can see, that it has connectives like OR, AND, followed by this kind of stuff. So, usually it is actually a way of expressing string patterns, but it is more than regular expression, because it has all these different type of operators. So, that is what it is like. And we do not need to learn this patterning language here, but just to give you an idea. So, here we are saying that when you are writing a pattern, you are writing that this IPv4 address or that IPv4 address followed by a particular specific domain name within 600 seconds. So, if you see anything like that in the traffic pattern, for example, then it is an indicator, right. So, that is what you are saying, right. So, you are saying an indicator. So, it has some temporal aspect, it has some sequencing aspect, and it has Boolean operators. So, it is kind of a mixture of things. So, just to give you examples, right. So, here is a bundle object, it has a bundle ID, and within the bundle object many objects, right. So, many SDOs and SCOs and SROs, right. So, here is an SDO within the bundle object. So, this curly parenthesis basically indicates the start of an object. So, this object has a type which is a threat actor, spec version, ID, created, modified, name, description. Then it has what threat actor type it is. So, here it is an array, it is a crime syndicate. Then it has aliases like whatever Equipo, Del, Discoteca. It has roles like agent, goals, the steal credit card information, sophistication, expert, resource level, organization, and primary motivation is personal gain. So, this threat actor is more like a criminal than a national level threat actor or something, but this bundle contains more things. This is just a beginning of an array. See, you see we have not finished this array. This array has first object in that array is this, there is a comma here, which means this object is finished, now the next object will start. So, here is an identity object. So, this identity object starts here, ends here, and you have some information about that identity, like the identity ID, description, name of the identity object, what class of identity it is an organization, it also has a contact information. Now, the third object inside the bundle is the relationship object, which has an ID, and the relationship is attributed to. Here is a threat actor and here is an identity. So, this threat actor is attributed to this identity. So, if this identity is ever mentioned, it basically means this threat actor, and any other information related to this threat actor will be relevant, right. So, this is how this relationship is this. So, this is one example. Here is another example, again given as a bundle. So, the objects in the bundle is an indicator and then other things. So, you see that this object is actually ends at that comma at the very end. So, it is an indicator, it has an ID created, modified, it has a name, it is a file hash for poison ivy variant, a particular variant of poison ivy malware. This file hash indicates the that a sample of poison ivy is present. It is an indicator type, malicious activity. Now, the pattern, right. So, pattern type is STIX pattern, and you see that it is basically a pattern that says SHA-256 of the file is so, and it is valid from certain date. So, this is one object in this bundle. We will go and see the next object. So, there is an indicator object, and here is a malware object. The malware object finishes in the comma here down on the left. So, malware name is poison ivy, it has a it is a remote access trojan, it is not a family, it is just a single special case. Now, a relationship object relates this malware to that indicator. So, it says indicates this that indicator that we saw, the hash that we saw indicates that the presence of this malware. So, this is the relationship. So, this is now the entire bundle completes. So, this is a small example. Now, marking. So, marking is example, like we said that marking is for traffic light protocol or something, like to say whether something can be shared, whether something has to be suppressed, etc. So, you see that in this example we have again a bundle. Within the bundle there are objects. Within the objects array, first object is an identity, and this is the Stark Industries name, and it has an ID. It is a defense sector industry. It has a contact information. Second object there, the opening bracket is missing in that on the top. No, actually it is there, but it is kind of hidden by the marking, the header marking, but the indicator is actually known IP addresses. So, it is for there is a pattern IPv4 address is 10.0.0.0 and pattern type is STIX, valid from object marking reference. So, it is now referencing two markings which we will look at later, right. So, marking definition and marking definition, they are saying, so it is saying something about this indicator, that this indicator is not free to be shared, it has some marking. So, let us see what those markings are. So, marking definition, first marking definition says it is amber, so it can be shared within the organization, and then second one is saying that there is a copyright of this indicator to Stark Industries. So, that means that Stark Industries created this threat intelligence, and they created that indicator object to let others know about what IP address can be seen for this particular malicious activity, but they have put some restriction on the sharing of that information. So, that that is basically how it is written, right. So, that is all I wanted to say about STIX, and you have already seen that we have this STIX viewer. So, you can go to the STIX viewer and you can actually you can put one of the STIX files there. For example, I can try to put this one that I had here, if there is no mistake. If there is a syntax problem, then it will not work, but I can try. Okay, so this does not have a relationship object, I guess. Let's see. There is a relationship object. I don't know if couldn't parse it properly or what. Well, it's just showing two SDOs. One is indicator, another is the identity object, threat actor. It's a threat actor identity object, but it's not showing the rest of the information. Okay. Well, I have to check, but you, when you, for your homework, when you write your STIX file, you can use this to actually visualize, to check. Okay. So, any other questions? Yeah. What? Pattern and bundle. No, so bundle is a meta object. It is for clubbing things together, right. So you are saying that like in C, well, C is not the right example, but you know you cannot write standalone set of functions, right. So you have to put a main, and from the main the functions have to be called, right. So bundle is sort of like the top level object within which you are putting an array of SDOs, SCOs and SROs, right. Now each SDO, some of the SDO and SCO may have patterns in them, right. Otherwise bundle and pattern has nothing to do. No, so report is different from bundle, right. So bundle is usually may contain a report, right. So bundle is basically the top level object in most STIX files. We put them as a bundle. Yeah, report will still be an SDO, so it will be inside a bundle. So I don't think that it can refer it. I don't know, but most probably, I mean, ideally it should be able to reference ID of another bundle, right. So because otherwise, if you see that let us say I have some threat intelligence in some STIX file, and I want to, but see there is a bundle ID, which means other bundles should be able to refer to this bundle, right. So, similarly, I would think that a report should be able to also reference another bundle to just reference to a threat report, but I have not seen it because I am not using it on a daily basis. So, those who are using STIX on a regular basis, they can tell you more, on that kind of nuances. No, so there are tools, right. So normally you do not do this yourself, right. So I'll show you that what was that tool. I was looking at it earlier today. A Scout Threat, right. So Scout Threat is a tool which which allows you to threat intel, creation of threat intel. So when you are creating this, it will automatically generate those IDs and stuff. So you do not do this manually very often. You can, but then you have to know how to generate the IDs and stuff. Okay, so I think we are done with the STIX. So the reason why I wanted to cover STIX is that if you go and work for security in an organization, and they are using threat intelligence from NCIPC or CERTIN, etc., you will encounter STIX and TAXI and all that. So you are going to be familiar with STIX, and also you will be probably be able, if you do your homework, then you will be able to probably do some further processing of STIX information, enrich it with further information and so on. And then you also understand, what are the components of threat intelligence, what is it that threat intelligence contains, right. So threat intelligence contains mostly information about threat actors, malware, various indicators, and there are 18 types of observables, this kind of stuff. So that gives you some basic idea about these things. Okay, all right.